We grow up with the idea that the number 1.618, the golden ratio, is a universal blueprint for aesthetics. We're told it's the divine proportion, a mathematical constant found everywhere, from ancient history to modern branding. It's widely cited as the foundation of classical architecture, particularly in the structural proportions of the Parthenon. We are taught that the Egyptians used these same geometric principles to engineer the Great Pyramid of Giza. And we see it in the most famous depictions of the human body, where Renaissance masters supposedly used it to map out ideal physical proportions. The narrative suggests that this number is a built-in standard of design, a ratio that is fundamentally tailored to please the human eye. However, to see how these claims hold up against the evidence, we first have to look at the actual math. Euclid originally defined the golden ratio in his geometric texts as a purely mathematical problem, completely independent of any artistic or aesthetic theory. This is the core mechanic. Divide a line so the ratio of the whole segment to the larger part is the same as the larger to the smaller part. That geometric division results in an irrational number stretching into infinity, 1.618033, and on. This geometric rule has a famous arithmetic sibling, the Fibonacci sequence. It's a series where every number is the sum of the two preceding it, 1, 1, 2, 3, 5, 8, 13, and so on. This chart shows the quotient of these numbers. Dividing any Fibonacci number by its immediate predecessor gets closer and closer to 1.618 as the sequence grows. This suggests the golden ratio isn't an arbitrary choice made for beauty, but a property of recursive numerical growth. This math manifests in the physical world through a biological phenomenon called phyllotaxis, the specific arrangement of leaf shoots around a plant stem. When you divide a circle by the golden ratio, you get the golden angle, approximately 137.5 degrees. Because phi is irrational and never resolves into a simple fraction, turning exactly 137.5 degrees for every new leaf ensures that no shoot will ever perfectly overlap with the one below it, allowing every leaf to capture the maximum amount of sunlight. That same principle of optimization governs complex, non-repeating geometry. In Penrose tilings, specific shapes can fill an infinite plane without ever forming a repeating pattern. This is only possible because the ratio of their side lengths is exactly phi. In nature and geometry, the golden ratio is a functional tool for spatial optimization and symmetry, rather than a subjective standard for beauty. This brings us back to the examples we often see in nature, like the nautilus shell. This overlay shows the actual growth of the nautilus. While it follows a logarithmic spiral, the growth rate of the chambers does not match the 1.618 golden proportion. The same discrepancy appears when we re-examine ancient architecture. Modern historians and mathematicians have found no textual or structural evidence that builders in Greece or Egypt intentionally used this ratio. Even the psychological claim that we naturally prefer golden rectangles has been challenged by rigorous studies since the 19th century, which consistently fail to show any inherent human preference for that specific shape. Finding the golden ratio in these artifacts is often the result of modern observers retrofitting data, drawing boxes over ruins until they find the numbers they are looking for. We are moving toward a view of the golden ratio based on mathematical literacy rather than the mystical, divine proportion. Moving past the romanticized myths doesn't diminish the number, it reveals a more complex truth. In the physical world, phi functions as an engineering mechanism. It coordinates the microscopic symmetry of crystal lattices and the structural layout of forests. The reality of an irrational number that governs the optimal growth of life seeking the sun is a more compelling story than the simplistic myths we invented about it.